Hello. Now we are going to look at the intersection of lines and circles, so where lines and circles cross each other. This is really just doing simultaneous equations with a quadratic equation and a linear equation. So the same tools that we know from algebra we can use directly here because the representation of a circle involves something that like a quadratic, and we have straight lines, which are the same as linear equations. These are the steps. We're going to do them in practice and then look back at the English of this. So if I look at my first situation here, I have a circle and it's x squared plus y squared is equal to 20. So I recognize that this is x squared plus y squared is equal to or squared. It's a circle centered at the origin at 0, 0. And then I just have the equation of a straight line. I don't have any squares or cubes or anything like that on my x's and y's. So I'm looking for where these lines, or where this green line, the equation of it's here, intersects or crosses my circle. And I can see that that happens at in the door 2 up the stairs 4. So I can see that that happens at 2, 4. And I can see that that happens at in the door minus 2 up, in the door minus 4 up the stairs 2. So visually, I know that those are going to be my points of intersection, but now we're going to look at the steps we can take to solve these two equations simultaneously in order to find the answer using algebra, because that's what we have to be able to do in our exam. So the steps that we take are, we take the line equation and we're going to rewrite it so we have x or y, one of our letters, is equal to everything else. We write the equation in terms of either x or y, and the way we pick whether we go with x or y is which one is going to let us avoid fractions. So here, if I tried to isolate y, if I tried to get y by itself, I'd have to divide everything by minus 3 at some point, which would leave me with an unpleasant fraction. So I'm going to get x is equal to everything, because that I can see isn't going to involve me having to do fractions. So I'm going to write my line equation and I'm going to get x by itself. So I rearrange my equation. I want x by itself, so I don't want that 3y there, and I don't want that 10 there. So I'm going to rearrange in order to get that by itself. So x must be equal to 3y minus 10. So that's my first step. Get my line equation where it's one of the letters is equal to everything else, and I want to do my best to avoid having fractions involved. Now I'm going to take this value for x and I'm going to sub it in to the circle equation. I'm going to do a substitution. So anywhere I have x in my circle equation, I'm going to sub in 3y minus 10. So I have x squared plus y squared is equal to 20. And I'm going to say anywhere there's an x in this equation, I'm going to put in 3y minus 10. So x is 3y minus 10 to be squared plus y squared is equal to 20. Now I can see that I have something that looks like a quadratic that only has the letter y in it, so I'm going to tidy this up and see if I can solve that quadratic. So I multiply out my bracket. So this is 3y minus 10 times 3y minus 10 plus y squared is equal to 20. I multiply out my brackets. So 3y on 3y minus 10 minus 10 on 3y minus 10 plus y squared is equal to 20. 9y squared minus 30y minus 30y plus 100 plus y squared is equal to 20. Add up my like terms. I have some y squareds here. So I have 10y squared in total minus 60y plus 100 is equal to 20. For a quadratic, I generally want to have everything equal to 0 in order to solve it. So I'm going to get that all equal to 0 by subtracting 20 from the right hand side, and to keep the balance, take 20 from the left hand side. So I have 10y squared minus 60y plus 80 is equal to 0. Now I can see I have a common factor of 10, so I can divide out number common factors. I wouldn't want to do this if it was a common factor of a letter, but I can divide out number common factors. I get y squared minus 6y plus 8 is equal to 0. And now I factorize my quadratic. So I look for the factors that would multiply together to give 8. So I have coefficient of 1 here. So my guide number would be 1 by 8 is 8. So I'd list all of my factors of 8. So I'd have 1 by 8, 2 by 4. And they don't work but to get the minus 6, but I could do minus 2 times minus 4. That would multiply together to give my guide number of 8, and it would add together to give my minus 6 in front of my y. So that's how I'm going to break up my quadratic. Y squared minus 2y minus 4y plus 8 is equal to 0. We can also use the minus b formula if we're stuck, but we can try doing our factorizing first. But the minus b formula will always work. Minus 4 on y minus 2 is equal to 0. So we end up with y minus 2 and y minus 4 is equal to 0. So y, break up my two solutions, if both of them are equal to 0, then y minus 2 could be equal to 0, or y minus 4 could be equal to 0. Rearranging both equations, I get that y should be equal to 2, or y should be equal to 4. But I haven't done yet. I need my x values for both of them. So x, I go back to my line equation. So I know x is equal to 3y minus 10. So I know that x should be equal to 3y minus 10. So I sub back in. So x should be equal to 3 on 2 minus 10. X should be equal to 6 minus 10 is equal to minus 4. So this point of intersection would be y is 2, x is minus 4, 2. And this one, I would have x is equal to 3 by 4 minus 10. Sorry, bracket in the wrong place. 3 by 4 minus 10, my apologies. And I would end up with x is equal to 12 minus 10, x is equal to 2. So I would have x is 2, y is 4 for my other point of intersection. And I got the same thing as I did from looking at my picture. Now we're going to do the same thing here. And we have our circle, again centered at the origin, and we have the equation of our straight line. Now this intersection we can see is only happening at one point. So last time we had 2 points of intersection. Here we can only see 1 point of intersection at 1 minus 2. This is called a tangent line when it only touches the circle once. Where we have 2 points of intersection, it's called a chord, and 1 point of intersection is called a tangent. So what we're going to do now is see what that looks like algebraically. What we're going to do is get a quadratic that has a repeated root, because there's only one solution, there's only one point of contact. Or the line only crosses the circle at one point. We still have to do the same thing, all of the same steps. So we have x minus 2y minus 5 is equal to 0. Again, x is the one that I can get by itself without a fraction. That's not always going to be the case, but in this example it is. So I want to get x by itself. So I add 2y plus 5 to both sides. So x is going to be equal to 2y plus 5. Again, sometimes it makes sense to get y is equal to, sometimes it makes sense to get x is equal to. Now I know that for my circle, x squared plus y squared is equal to 5. So I want to sub in my value for x, 2y plus 5 to be squared plus y squared is equal to 5. Multiply out my brackets as before. And we're just tidying everything up so we can solve our quadratic. So we'll do 2y on 2y plus 5 plus 5 on 2y plus 5 plus y squared is equal to 5. 4y squared plus 10y plus 10y plus 25 plus y squared is equal to 5. Add up like terms. So I have 5y squared plus 20y plus 25 is equal to 5. It's a quadratic, so I'm going to get everything equal to 0. So 5y squared plus 20y plus 20 is equal to 0. I see I have a common factor of 5, so I'm going to divide both sides by 5. So I get y squared plus 4y plus 4 is equal to 0. And I factorize this. Or I could use my quadratic formula to solve it, which is what I'm going to do here, just to give a contrast. So we did factorizing, now we can use the minus b formula. So we write down our formula from our log tables and sub in. So a is equal to 1, b is equal to 4, c is equal to 4. So subbing into our equation, we have minus 4 in brackets plus or minus the square root of 4 squared minus 4 on 1 on 4. And something a bit unusual happens for using our minus b formula. We get y is equal to minus 4 plus or minus the square root of, when you put all of this into your calculator, you actually get 0. So when we get a repeated root, there's only going to be one solution that comes out of this formula, because plus or minus 0 doesn't do anything. So our value for y is just going, there is no plus or minus business. Plus or minus 0 helps nothing. So we end up with minus 4 all over 2, which is just minus 2. Then we can go back and say, well, x is supposed to be equal to 2y plus 5. So x would be equal to 2 on minus 2 plus 5 is equal to minus 4 plus 5 is equal to 1. So our, I've run out of space, our point of intersection is x is 1, y is minus 2, just as we found in our picture. So that's how we can use factorizing or our minus b formula to solve that quadratic. And we have all of our steps, the same steps as we have for finding the intersection between a quadratic type equation and a linear equation that we would do in pure algebra. And that is what we need for now.